The final problem on our rational functions practice quiz is asking us to sketch the graph of this function here. And it's a pretty simple rational function. First degree polynomial on top, first degree polynomial on bottom. And let's just be clear, we need to show the asymptotes and the axis intercepts and label our axes and show the scale. So let me just start there. I'm going to draw my axes. Just sketching a nice straight set of axes. And I'm going to label them. This is X, this is Y. There we go. Label your axes. It asks us to show a scale too, so I might just mark off 1, 2, 3, 4, 5. Mark off a scale like that. A lot of times when I draw a scale, instead of labeling every single one, I might just label every fifth one. So there, I've shown my scale. I could extend this a little farther if I wanted. But this should be enough to produce a pretty nice looking graph. So again, when we have a rational function like this, the first thing we think about is after we draw our axes are the vertical asymptotes. And remember, vertical asymptotes happen when at the values of x that cause the function to be undefined. And so if you look at this function right here, when x is equal to 4, the denominator becomes 0, and that would cause division by 0, which is undefined. So x equal to 4, there's an asymptote at x equal to 4. So let me go to 1, 2, 3, 4. There's x equal to 4 right here. And I'm just going to draw my vertical asymptote. It's just a dotted line. Okay? Just like that. So let me label it. X equals 4. Now, horizontal asymptotes, we figure those out by thinking about the end behavior of this function. And remember, for large x, I can say that y is approximately equal to 3x over negative x. Let me just show you why. If I pick a really big number for x, like let's say 1 million, on the top I get 3 million here minus 1. That minus 1 doesn't matter if I have a really large value for x. On the bottom, I get 4 minus 1 million. Well, that's about negative 1 million. The 4 doesn't really matter very much when I'm talking about a really, really big value of x. So basically, I can, instead of thinking about what happens with this function, I can kind of think about this simpler function, right? And of course, this is just negative 3. So y comes closer and closer to negative 3 as x gets bigger and bigger and bigger and bigger. This also happens for negative x values. If you think about a really big negative value like negative 1 million, the top of this becomes negative 3 million, and the bottom becomes a positive million. So negative 3 million divided by 1 million is still negative 3. So whether I'm going all the way to this end of the graph or whether I'm going all the way to the other end of the graph, this function approaches negative 3, y equal to negative 3. So let me go to 1, 2, 3, negative 3 here and draw my horizontal asymptote right there. Okay, and I'll just label that y equals to negative 3. That's my horizontal asymptote. So normally I would just kind of test some points and draw my curves wherever they end up. But here I'm asked about the intercepts. And so let me locate the x and y intercepts by just, first of all, the y-intercept is pretty easy. I'm just going to plug 0 in for x. At the y-intercept, x equals 0, so y equals 3 times 0 minus 1 over 4 minus 0. And this just equals negative 1/4. So negative 1/4 is when x is equal to 0, y is negative 1/4. That's about right there. All right? And that gives me a pretty nice point to locate the rest of this curve. I'm going to draw that curve and just show it approaching these asymptotes there and there. And that kind of informs maybe an x-intercept also. Let me just label this 0, negative 1/4. But let's just do the math for the x-intercept. At the x-intercept, the value of y equals 0. So I want to solve this equation. 0 equals 3x minus 1 divided by 4 minus x. Now, obviously I can't have x equaling 4 in this equation, but I know that if the top is equal to 0 and the bottom is non-zero, then my quotient will be 0. So really the equation that I'm trying to solve here is this one, minus 1. Okay, so solving this equation using the properties of equality, I get x equals 1/3. So when y equals 0, x is equal to 1/3, and that's right about there. All right, so I'll just label that point 1/3, 0. And now I've got my x and my y-intercept. Now I'm just going to kind of test a point on this half of the graph to make sure I draw the other half of the curve in the appropriate place. So let me just think about 5, x equal to 5. And if I plug 5 into this function, I get 15 minus 1, I get 14 on the top. And 4 minus 5, I get negative 1 on the bottom. So 14 divided by negative 1, that's negative 14. So when I put 5 into this function, I get some point like somewhere down here, negative 14. And that just tells me that this curve is gonna be in this quadrant that's defined by the asymptotes. And so I'll just draw that in. And there's my graph. Just go back to the directions and make sure that I showed my asymptotes. I did that, the vertical asymptote and the horizontal asymptote. Make sure to show asymptotes and axes intercepts. I did my x-intercept and my y-intercept. And then I labeled my axes, x and y. And in this case, I showed my scale. I just counted off by ones. So there's my graph.